Hello there, alrighty. So, here is your pre-lesson video for week 1.1 integers. So, let's get started. So, you're probably going to be wondering, what are real numbers? So, real numbers are any number that appears on the number line. So, we'll get into a second what the number line is. So, essentially, the number line will look like this, right? Remember this thing with numbers labeled all over there. So, a real number will appear on the number line whether it is positive or negative. Positive or negative numbers, right? And it can include every fraction, decimal, whole number, and even the zero, right? So it can be positive, negative, fraction, decimal, whole number, zero. So those are real numbers. And then for non-real numbers, so non-real numbers are a number that can't exist in real math, and therefore it can't be on the number line, right? So there are two types of non-real numbers that will appear on your test, which are numbers that are divided by zero. So you can't have anything be divided by zero. That's just mathematically impossible. As well as the square root of a negative number, which is also known as the imaginary number, and we denote it as I. And we'll actually cover that in a bit further down our lessons, right? And now you're probably wondering also, what are whole numbers? So whole numbers are any positive integers and does not include zero. So any numbers like 1, 2, 3,000, 5,000,000, and so on, as long as they're a positive integer. And now, integers themselves are any number, whether it's positive, negative, or zero. So positive, negative, or even zero. Just any number. That's positive, negative, zero. It can be written without a fractional or decimal component. So essentially, an integer is like 1, 2, 5, -1, -10, and so on. So it's not a fraction and it's not a decimal. Those would not be considered integers, right? And now if we look down, the number line is a line that represents the spectrum of all real numbers and symbolically extends infinitely on both ends. So if you look, this would be your number line. See how there are two arrows pointing in each direction? So as we go to the left, it will be becoming negative, and as we go to the right, it will become positive. So like, say this is 0 here, this is -1, -2, 1, 2, 3. So as we move from left to right, it is becoming positive, and as we move from right to left, it becomes negative. Now, absolute value, what is that? So it is an expression's distance from 0 on the number line. So absolute value is always positive because distance can't be negative, right? There's no such thing as a negative distance. So that means -5, for example, is 5 units from 0. The absolute value of -5 will be written with these absolute signs. See how there's two lines there? Right? Which means it is 5. So that means even on the number line, say we draw this, we have a few. So we have 0 here, 1, 2, 3, -1, -2, and -3. Say we take this point here, right? In terms of distance, we'll write it as -3 in absolute signs, which means the distance from 0 is just 3. So, as I mentioned before, absolute 0 is always positive. All right? Now, very big thing with your operations and stuff is you have PEMDAS. Now, this is very important. So, PEMDAS, that stands for P is parentheses, E is your exponent, M is multiply, D is divide, A is add, and S is subtract. Right. Now with PEMDAS, remember, P and E go together, M and D go together, and A and S go together, which means that you need to do the order of your operations from left to right, but from left to right, and you would have to follow PEMDAS. So if, let's say, you were given a parentheses and exponent first, you would have to do that. If you were given multiplication and division, you would do those after you did the parentheses and exponent. And so we'll show you some examples in a tiny bit of how to do the order. So if division comes before multiplication, you would do division first, right? From left to right. It would, so as you can see, these ones that are grouped together, you would do them from left to right. And we'll see in a second as I show you the example also. And then same thing with addition and subtraction. If subtraction comes first, which means on the left, followed by addition, then you do subtraction first, followed by addition. So the order of doing this is from left to right, parentheses, exponent. So whichever one comes first from left to right, you would do that. Followed by multiplication, division, whichever one comes first from left to right, you would do that. And then lastly, you will have addition, subtraction, left to right, whichever one comes first, you will do first. All right? If any questions about that, bring that during the deep dive lesson. Now, a very big thing to remember when you're doing your operations are the sign rules, right? So this normally applies only when you are dividing and multiplying and dividing, right? So it goes back and forth. So if you have positive times positive or positive dividing positive, you will get positive. If you have negative times negative or negative divide negative, you will get negative. Now if you get positive times negative or the other way around, if you're dividing positive with negative, you'll get, this will become positive. So negative times negative will become positive, and then positive times negative will become negative. Negative times positive will become negative. Now, as you can see here, one thing to remember really quick, if they are the same sign, they will become positive. And if they have different signs, right, so different signs, they will become negative. So positive times positive becomes positive, negative times negative becomes positive, and so same signs becomes positive. Positive times negative becomes negative, negative times positive becomes negative, and so since they're different signs, it will become negative. Now let's say you are given an operation with 3 terms, right? It is a lot easier if you just break it down 2 at a time. So like if you have positive, negative, positive, do the positive and negative first, which will give you negative, and then the negative and positive would then give you a negative, right? So just break it down 2 at a time. Now for addition and subtraction, right? So if you are adding or subtracting, you want to take the sign of the biggest number. So you want to take their sign. And we'll see in a second what I mean by take their sign, all right? So here are some example questions of how you want to do order of operations, since it is very, very important. So as we look here, right? Here, parentheses and exponent. From left to right, we will do the inside the parentheses first, because that'll be a lot easier, right? So 27 divided by 3 will give you 9, and then we'll put a square, minus, and then look, this one is also in parentheses, so we'll do that first. So negative 3 times 4 is negative 12, And then the next thing we need to do is the exponent, as you can see here. So then 9 squared would become 81. Negative times negative, oh look, so same signs becomes positive 12. So 81 plus 12 would equal to 93. And that's the answer. That's one example. If you have any questions about this, obviously bring it through the deep dive lesson. And now the next one. Oh look, again, parentheses and parentheses, but we have many more terms in here, right? So the first one that we want to do with this one is, if you look from left to right, we have plus and then times, right? And we know from PEMDAS we need to do times first. So, oops. So let's do, we'll leave 9 as it is, plus 3 times 6 is 18, plus, and then we're going to do inside of this one first. So if we do from left to right, we will need to do 12 divided by negative 6, which becomes negative 2, minus, oh look, an exponent. So 10 cubed would become 1000, right? So we'll get that now. And now, because we still have the parentheses, we would solve the insides first. So 9 plus 18 is 27, plus, oh look, negative 2 minus 1000 will become negative 1002, right? And then from here, we would do 27 plus negative 1002, right? So if we can see, because we're now adding and subtracting, we would take the sign of the biggest numbers. And so we know our biggest number, ignoring the sign, is 1002. So that means our sign is going to be negative 975. And that will be the answer. Does that make sense? All right, if you have any questions about this, again, as usual, bring it to the deep dive lesson. All right. And then for the next one, we have absolute signs. Okay. So absolute signs, again, same thing, is they're like parentheses, but you want to do the insides first. But just remember that your solution in the end will become positive. So let's put absolute sign here first. So 4 times 5 is 20, close absolute sign, minus negative 81 divided by 9 will become negative 9, close absolute sign, right? Now if we open the absolute signs, we're going to get 20 minus 9. Because remember, anything inside the absolute signs will become positive. So that negative 9 will become positive. And then this negative sign over here is still a negative because it's not inside the absolute sign. So it is as it is. Right, so that's why we have 20 minus 9, which would then equal to 11. And that is the answer for this one. All right, if you have any questions about absolute signs, absolute values, again, bring it to the deep dive lesson. All right, now, these ones are more for application. And you will see this more often in the test. So, while doing a problem on his calculator, Tom meant to divide a number by 2, but instead he accidentally multiplied the number by 2. Which of the following calculations could Tom then do to the result on the calculator screen to obtain the result he originally wanted? So imagine this. Let's take the number 1. He at first wanted to divide it by 2, right? So that would have given him half. But instead, he had multiplied by 2, which gave him 2. And so what do you think would we need to do in order to get half? So if we try this, we'll do the opposite. So in order to get back 1, we will need to divide by 2, right? Which would then give us 1. And then we need to divide by 2 again in order to get half. So we do half times half, which would give us by 1/4. So that means essentially he would need to divide 4, so E, in order to get his answer. Or he could do, or like if he did a mistake and he wanted to get the answer that he originally wanted, he would need to divide by 4. Another way to see this is, how do we make 2 become half, right? So if you think about this, 2 divided by 4 equals to half. So that's another way that you can also think about it. All right. If you have any questions about this, bring it up during the deep dive lesson. And then this other one. So a party special at Dana's Bakery contains exactly 1 cake, 1 pie, and 1 bread. How many different party specials are possible when choosing from 6 cakes, 7 pies, and 12 breads? So we're talking about combinations that can change, right? So we want 1 cake, 1 pie, and 1 bread. So what we would need to do in order to find this answer is essentially just do 6, because we have 6 rotations of cakes, times 7, because we have 7 rotations of pies, and times 12, because we have 12 rotations of bread. And so we would multiply all those together to give us, so 6 times 7 times 12 would give us 504. And so that means there are 504 party special combinations that is possible when choosing from 6 cakes, 7 pies, and 12 breads. Alright, and so this is the end of your pre-lesson video. If you have any questions about any of the material, please bring it to the deep dive lesson. Alright, have a good rest of your day.